problem 21 is all about the deck of cards. So I said, in case you're not familiar with the deck of cards, you can have a look at this picture and suppose that you draw a single card from a 52 card deck. Part A says, what's the probability that you will draw an ace or a king? Express your answer as a single fraction. So I'm going to move this up just a little bit. So we want the probability of an ace or a king. So the first thing you have to ask yourself is, are these things mutually exclusive? And yes, they are. Okay, and the reason they're mutually exclusive events is because there's no way I could draw an ace and a king at the same time if I'm only drawing one card. So that being the case, we proceed as, well, this is just the probability of getting an ace, and we add that to the probability of getting a king. So the probability of getting an ace is, well, look over here. Where's my aces here? My aces are just the ace of clubs, diamonds, hearts, and spades. So there's only 4 out of 52 I could get for that one. And then the probability of getting a king, well, my kings are over here. Well, that's also 4 out of 52. So that's a grand total of 8 out of 52, which I believe I gave you an answer of 2 out of 13 when you reduce the fraction as a single fraction. Okay, now then part B says, what's the probability? I'll shrink this down just a little bit so we can still see. And it says, what is the probability that you will draw a diamond or a queen? Okay, so for part B, it's asking, what's the probability of getting a diamond or a queen? And again, ask yourself, are these mutually exclusive events, yes or no? And the answer is no, they're not mutually exclusive, because if I'm only drawing one card, I could get the queen of diamonds. So we proceed as follows. We say this is the probability of a diamond. We're going to add that to the probability of queen, and then we're going to subtract the probability of both happening together at the same time. So the probability of getting a diamond is just 13 out of 52. The reason being is because there are 13 diamonds in the entire suit, in the entire deck, right? Okay, now we go to what's probably getting a queen. Well, that's just 4 out of 52. And then we just subtract off the probability that they could both happen at the same time. Well, there's only one queen of diamonds, and that would be right there. So we're going to subtract off 1 out of 52 because we've overcounted. So this gives me 13 plus 4 is 17, and then 17 minus 1 is 16, so I'm getting 16 out of 52, which simplifies to 4 out of 13, and that's how I got the answer.